ओके सो पिछले लेक्चर में हमने बात की थी डिफरेंट फॉर्म्स ऑफ कंडेंसेशन, जिसमें हमने देखा था ड्यू, फ्रॉस्ट, राइम, मिस्ट, हेज एंड फॉग। फिर हमने देखा था कि फॉग कैसे फॉर्म होता है। द आइडियल कंडीशन फॉर द फॉर्मेशन ऑफ फॉग वॉज टेम्परेचर इन्वर्जन। जहाँ जहाँ पे देयर विल बी अ सडन ड्रॉप इन द टेम्परेचर ऑफ एयर, देयर वी विल सी टेम्परेचर इन्वर्जन एंड दिस विल लीड टू द फॉर्मेशन ऑफ फॉग। और हमने फिर डिफरेंट टाइप्स ऑफ टेम्परेचर इन्वर्जन के बारे में पढ़ा था, जैसे कि रेडिएशन, एडवेक्शन, फ्रंटल, एयर ड्रेनेज एंड अपस्लो फ्लॉग, एंड दिस ऑल लीड्स टू द फॉर्मेशन ऑफ फॉग. So this was the ideal condition for the fog formation. अब हम पढ़ने वाले हैं स्टेट ऑफ स्टेबिलिटी एंड इनस्टेबिलिटी. सो हमें पता है कि जो हमारा सरफेस है, ठीक है, हमारा जो सरफेस है, इट absorbs the short wave radiation coming from the atmosphere. It holds it for some time and then radiate long wave radiation in the atmosphere. This whole process is known as insolation, in which heat is taken and heat is transferred. ठीक है, हमारा जो सरफेस है ना, इट इज़ अ सोर्स ऑफ हीट ट्रांसफ़र, सोर्स ऑफ एनर्जी ना, इट इज़ अ सोर्स ऑफ हीट ट्रांसफ़र. हीट इज़ ऑब्जर्व्ड एंड हीट इज़ गिवन आउट. ठीक. सो there is a three type of heat transfer, three ways to transfer heat: convection, conduction and radiation. So in this we are going to talk about convection. कन्वेक्शन में क्या होता है कि हमारा जो एयर है नियर टू द सरफेस, इट एब्जॉर्ब्स हीट व्हेन द हीट इज़ वेरी हाई ना, very high heat, temperature is very high, the air absorbs the heat and it start moving vertically upward. The air start rising. In the vertical movement, the air start rising. The rising air at the higher altitude, it keep on expanding. वो rise भी होते जाता है और साथ ही साथ expands होते जाता है. और साथ ही अपने साथ moisture भी कैरी करता है. और एक बहुत ही हाई एल्टीट्यूड पे हम कह सकते हैं द एंड ऑफ द ट्रोपोस्फियर, इट गेट कंडेंस, ठीक है, फॉर्म्स क्लाउड विच लीड्स टू द प्रेसिपिटेशन, इट कॉजेज रेन. सो दिस इज़ द होल प्रोसेस ऑफ कन्वेक्शन. तो कन्वेक्शन में क्या होता है, द एयर कॉलम अबव द सरफेस, ठीक है, हमारा जो सरफेस है ना इज़ अ सोर्स ऑफ हीट फॉर द एंटायर सरफेस, सोर्स ऑफ एनर्जी. सो द एयर कॉलम अबव द सरफेस, इट एब्जॉर्ब्स द हीट को एब्जॉर्ब करता है एंड स्टार्ट राइजिंग अप एंड एक्सपेंड्स ना, देर इज़ अ वर्टिकल मूवमेंट ऑफ एयर. सो कन्वेक्शन इज़ यूजफुल फॉर द ट्रांसफर ऑफ हीट फ्रॉम द लोअर सरफेस टू द हायर एटमॉस्फियर एंड ऑल्सो इन द ट्रांसफर ऑफ water vapor. It also transfer water droplets. It carry water droplets. The air, it carries water droplets with it. ठीक है. So हम बात करें स्टेबिलिटी एंड इनस्टेबिलिटी कंडीशन की. सी, for the rain to cause, for the precipitation to happen, there should be instability in the atmosphere. अगर कोई instability नहीं होगा, so there will be no rain, no formation of clouds. ठीक है. So instability, it is a condition where the air does not resist vertical movement. यहाँ पे एयर जो है वो वर्टिकली मूव करता है अपवर्ड एंड लीड्स टू फॉर्मेशन ऑफ क्लाउड, ठीक है, एंड प्रेसिपिटेशन. It is more common in the regions of high temperature at the surface where there is high temperature. In such region, the instability takes place. For example, best is our equator. At the equator, the temperature is very high and there is low pressure. That is when the air is heated from below. The air is heated from below. And also in the regions of low pressure. ठीक है. Next हम बात करेंगे stability की. So stability is a condition when air resists vertical movement. The air is stable at the surface. There is no movement of air, no disturbance in the atmosphere. It remains in its original position. So the air remains stable, means the air is cooled. The air is cooled at the surface. जहाँ पे air is heated, it leads to upward movement, and जहाँ पे it is cooled, it is stable. ठीक है. इट इज़ कूल एट इट्स बेस और व्हेन द एयर इज़ सबसाइडिंग अलॉन्ग द हाई प्रेशर. हमने प्रेशर बेल्ट के बारे में पढ़ा था, तो हमने ये देखा था कि जहाँ पे हाई प्रेशर होता है, जैसे फॉर एग्जांपल सब ट्रॉपिकल रीजन, देयर द एयर इज़ सबसाइडिंग, मतलब एयर इज़ सबसाइडिंग फ्रॉम टॉप टू बॉटम, इज़ कमिंग फ्रॉम टॉप टू बॉटम. वहाँ पे वी विल सी अ स्टेबल एयर. ठीक है. तो इन सच सिचुएशन द प्रेसिपिटेशन इज अनलाइकली, मतलब देर इज नो रेनफॉल, ठीक है, नो फॉर्मेशन ऑफ क्लाउड्स, नो प्रेसिपिटेशन, ठीक है. सो दिस वॉज ऑल द concept of stability and instability. So for the rain to happen, ठीक है, there should be instability in the atmosphere. Okay, next we are going to talk about the clouds, the different types of cloud, how the clouds are formed. So there is few terms which you need to remember to get it more, to make it more simpler. Okay, सो कुछ टर्म्स हैं जिन्हें हमें याद रखना है. तो सबसे पहला है सिरस. सिरस मीन्स हाई एल्टीट्यूड एंड फेदरी. इन दिस द क्लाउड्स आर फॉर्म्ड एट हाई एल्टीट्यूड एंड दे आर फेदरी. Second is alto. Alto is mid altitude. The cloud formation is at mid altitude. Third is the cumulo. Cumulo is cotton wool. Fourth is the stratus. Stratus means layered. Fifth is the nimbus. Nimbus means rain bearing. So these are some terms which will make our understanding of the clouds easier. So we'll talk about the common types of clouds in the troposphere. So they are cirrocumulus clouds, altocumulus clouds, cirrus cloud, altostratus cloud, stratocumulus cloud, stratus cloud, cumulus cloud and cumulonimbus cloud. सो चलिए एक एक करके सबके बारे में बात करते हैं कि ये क्या है, हाउ आर दीज फॉर्म. तो सबसे पहले हम बात करेंगे सिरस क्लाउड की. स्क्रीन पे आपको उनके जो शेप्स हैं वो दिख रहे होंगे, तो आप रिलेट कर सकते हैं. तो सिरस क्लाउड्स दे आर थिन feather like clouds. They are fibrous appearance. They are of fibrous appearance, white in color. They are at high altitude and indicate fair weather. ठीक. Second is cirrocumulus cloud. So they are patches of globular masses at high altitude. They appear like a globe. It's also called as mackerel sky. Third is cirrostratus cloud. So they are layered cloud at high altitude with milky appearance. Fourth is the altocumulus cloud. They are globular masses of cloud, cotton wool appearance at mid altitude. Fifth is the altostratus. They are the layers of cloud in sheets. They are in sheets form around mid altitude. Next is stratocumulus clouds. So they are globular masses of clouds with cotton wool appearance which are regularly arranged at low altitude. Seventh is the stratus cloud. So they are low uniform layer of cloud near to the ground level and they produce light drizzle. Drizzle means होता है low intensity rain. Next is cumulus cloud. So they are thick cloud of cotton wool appearance with dome shaped cauliflower top and horizontal base. So आप पिक्चर में भी देख सकते हैं the cumulus clouds. Cumulonimbus clouds are the overgrown cumulus cloud, very dark, heavy and dense with an oval top. ठीक. And they causes heavy showers, heavy rains with thunderstorm and lightning. मतलब जो हमारे cumulonimbus clouds हैं they are extended from lower level to the end of the troposphere. ठीक है. And they are responsible for the thunderstorm and lightning. ठीक है. So this was all about the clouds. So next we are going to talk about the rainfalls. Now, so in this we'll talk about the conditions which are suitable for the rainfall. So there are 4 conditions: evaporation, convection, cooling down and the dust particle. So हम सबको पता है when the water it is heated, it rises up and forms water vapor. So for the rain to form, for the formation, evaporation, the process of evaporation is the first step and is a very important. Second is the convection. The air rises up. ठीक है. The air rises up. It contains some moisture. It rises up in the vertical movement, vertical direction. It also it expands, and when it reaches to the high altitude, the air gets saturated. It gets condensed, cool down, and ना it get cools down, and then एटमॉस्फेयर में देयर आर ऑल्सो डस्ट पार्टिकल्स प्रेजेंट. ठीक है, तो वहाँ जो वाटर है ना, द वाटर वेपर, द वाटर पार्टिकल, इट कूल्स डाउन एंड इट स्टार्ट्स एक्यूमुलेटिंग अराउंड द डस्ट पार्टिकल. जो हमारे छोटे छोटे ड्रॉपलेट्स हैं वाटर, इट स्टार्ट एक्यूमुलेटिंग अराउंड द डस्ट पार्टिकल, जिसे हम कहते हैं कंडेंसेशन न्यूक्लियाई, एंड दिस लीड्स टू दी cloud formation and then precipitation. So this is the condition, suitable condition for the rainfall. So it is a mechanism to uplift the moist air. ठीक है, evaporation is the mechanism to uplift the moist air. Saturation and cooling of air below the dew point. When the saturation and cooling of air below the dew point is happen, this is the process of convection. Presence of condensation nuclei like dust particle around which the water droplet can accumulate. So this is all the process for the suitable formation of the rainfall to happen. So depending on the condition where it is happening, there are three type of rainfall: convectional rainfall, orographic rainfall, and frontal rainfall. So first we'll talk about convectional rainfall. So it occurs generally at the equatorial regions where the temperature is very high, the air is lifted up. ठीक है, so there the cloud formation is at higher possibility, and there the rainfall is also very high because of the high temperature, high intensity of sunlight. ठीक है, so it can happen, the convectional rainfall can happen anywhere during summer. It is not only possible that only at the equatorial region it will happen at different places also. ठीक है, so it happens in the region of intense heating, जहाँ पे heating बहुत ही ज़्यादा है, the temperature is very high near the ground surface, causing the air to expand and rise. So the high temperature, it causes the air to expand and rise. Often it is accompanied by thunderstorm and lightning. So such condition, it is accompanied by thunderstorm and lightning. So it is experienced throughout the year. It is experienced in equatorial region in summers. Now, so it is experienced throughout the year in equatorial region and during summers in other regions. So next is the orographic rainfall. So orographic rainfall is generally, it can be seen at the mountain areas. ठीक है, generally it is seen there only. So let's see क्या होता है कि orographic rainfalls are the one when a warm and moist air, ठीक है, गर्म हवाएं which carry moisture with it is forced to rise across mountain slope. It is forced to rise across mountain slope and it cools down. After reaching at the top, it cools down because there the temperature drops, causing precipitation, which causes precipitation. The air gets saturated there along the windward side. So however, on the leeward side of descending air, लीवर्ड साइड मतलब जो माउंटेन का अपोजिट साइड है ना, जहाँ पे एयर हमारा डिसेंड करने लगता है, जहाँ से वहाँ पे एयर राइज नहीं करता है, इट गेट डिसेंडिंग, देयर द प्रेसिपिटेशन इज रेस्ट्रिक्टेड लीडिंग टू द फॉर्मेशन ऑफ रेन शैडो रीजन. फॉर एग्जांपल हमारे वेस्टर्न घाट, क्योंकि मैं आपको दिखाती हूँ कि सो दिस वॉज द कंडीशन. यहाँ पे द एयर इज लिफ्टेड अप, ठीक है, एंड हियर ड्यू टू reaching at the top, the air gets saturated, which leads to the formation of clouds and heavy rain. But on the opposite side, the air get descending air, और जो हमारा descending air होता है ना, it heats up, it don't cools, it heats up, and the area which is near to this place, these are the rain shadow regions, especially हमारे जो western घाट्स होते हैं. So this was the orographic rainfall. Next we are going to talk about the frontal rainfall, that what are frontal rainfalls. ठीक है, so frontal rainfall, they are also called as cyclonic rainfall. ठीक है, it occurs along the frontal zones due to the convergence of different type of air masses. So when two different type of air masses like the warm air and the cool air, when they meet ना, they don't mix up. क्या होता है कि जब वार्म एयर और कोल्ड एयर टकराते हैं ना, तो मिक्स नहीं होते हैं. जो लाइटर एयर होता है वो उसके इट मूव्स ओवर द कोल्ड एयर, ठीक है, इट राइजेज अप. सो इट इज़ बेस्ट डेवलप्ड अलॉन्ग द पोलर फ्रंट्स where the warm air rises along the cold air causing precipitation. So this was the frontal rainfall. Here you can see the warm air and the cold air, they they are rising, the warm air is rising above the cold air, and the clouds formation is there, which leads to rainfall. ठीक है, and such condition is possible in the polar fronts, in the polar region. So next we are going to talk about the distribution of precipitation. So we'll talk at different latitudes how the precipitation is distributed. So first is the equatorial zone. So along the equatorial zone, along the equator, above 200 centimeter per annum, the rainfall take place due to convectional rainfall, due to high temperature and high humidity level all through the year. There is 200 centimeter per annum rainfall. ठीक है, due to high temperature and high humidity level. Next is the subtropical region. So subtropical region, there is minimum rainfall of 25 centimeter per annum due to high pressure, subsidence and offshore trade winds. Offshore का मतलब होता है offshore trade winds, मतलब कि from winds blowing from land to oceans. ठीक है. Next is the mid altitude region or the temperate region. So their average to above average rainfall happens between 100 to 125 centimeter. There the rainfall increases from interior towards the coastal regions. जो rainfall वहाँ पे होती है, it increases from interior towards the coastal region. Rainfall is due to onshore westerlies. It is because of the onshore westerlies. Onshore means the wind blowing from ocean to lands. Interaction of different air masses, the different air mass interacts along the fronts, and convection in summer. Convection takes place in summer. So all because of which mid altitude region it receives average rainfall. Next is the polar region. So at polar region there are low rainfall due to the low temperature. So next we'll talk that the oceans, they receive more rainfall due to moist maritime air masses. The air masses present over the oceans, they contain more moisture, which is a suitable condition for the formation of rain. So the oceans, they receive more rainfall as compared to the lands, continents. Also the coastal regions, they receive higher rainfall. The coastal regions, like you can see, they receive the higher rainfall than the interior due to the moisture laden offshore winds. जब भी हमारे जो winds है ना वो ओशन से जाते हैं लैंड्स की ओर, तो द कोस्ट दे रिसीव द हायर रेनफॉल. ठीक है, और जब तक वो इंटीरियर की तरफ पहुंचते हैं तो जो मॉइस्चर कंटेंट होता है वो ऑलमोस्ट ख़त्म हो चुका रहता है. सो बिकॉज ऑफ द कोस्टल रीजन दे रिसीव हायर रेनफॉल. ऑल्सो देयर आर विंड्स विच ब्लो पैरेलल टू द कोस्ट. ठीक है, दे ब्लो पैरेलल टू द कोस्ट एंड देयर इज नो प्रेसिपिटेशन फॉर्मेशन. दीज विंड्स डोंट फॉर्म एनी काइंड ऑफ प्रेसिपिटेशन व्हेन द विंड्स दे आर परपेंडिकुलर टू द so winds which blow parallel to the coast, they don't cause precipitation. Okay, so thunderstorms. So thunderstorms are formed due to intense heating and strong vertical convection. ठीक है, at the ground when there is intense heating, the air moves up vertically up and the process of convection take place. Cumulonimbus clouds are formed. So we had seen earlier that cumulonimbus clouds, they carry heavy rain which leads to thunderstorm and lightning. Okay, so the raindrops in these clouds, the cumulonimbus clouds, they move up and down. The raindrops, they move up and down, creating electric charges due to friction. So due to the movement of the raindrops in the clouds, there are electric charges which are formed due to friction. So gradually what happens that positive and negative charges, they accumulate on opposite sides of the cloud, positive and negative charges both. And when both the type of charges, they are attracted, so a flash of light is produced due to the attraction of the charges, due to exchange of charges, which is called as lightning. You can see in the figure. So lightning causes rapid heating of air and the expansion, which results in the creation of vacuum. It is filled by and that vacuum is filled by the surrounding cold air, producing a clap of thunder. So this is all the process how the thunderstorm forms. So in simpler term we can say that movement, there is movement of air, charge particle, electric charges are formed due to friction, then lightning take place. When the charges attract, then lightning take place, which creates vacuum, and then finally thunder storm. ठीक है, producing thunderstorm. Next we are going to talk about the cloud burst. So IMD defines cloud burst as a rainfall over 10 centimeter in 1 hour. So whenever there is a rainfall of 10 centimeter in 1 hour and it is concentrated over a small area a few kilometer, so that is defined as the cloud burst zone. Okay, so the process for the formation of cloud burst is the rapid convection of highly humid warm air. So whenever there is rapid convection, high temperature, high humidity level. Next, the condition for the formation of cloud burst is the funneling effect, which is experienced along the steep topography, which results in the growth of huge clouds without precipitation. So funneling effect में क्या होता है कि जो हमारे mountains होते हैं ना, तो the air blows, it is funneled, the air, the winds, they are funneled at this point. और अगर इसके पीछे कोई एक और भी माउंटेन्स है तो वो राइज अप कर जाता है ओवर दिस माउंटेन. द एयर कमिंग फ्रॉम हियर राइज अप टू दिस ओवर दिस माउंटेन like this. So in the funneling effect, the winds, they rises along the mountain slope. You can see here the wind which is funneled here, it rises along the mountain slope. So the funneling effect experienced along the steep topography, it results in the growth of huge clouds are formed but without precipitation. मतलब the air is saturated but still its capacity, it expands, it can acquire more, but it did not lead to precipitation at that point. ठीक है. Next, so after a point the rain drops become too heavy for the clouds to hold, but after some point the drops it become too heavy for the clouds to hold on and drops together in a quick flash, और सडनली सारा पानी एक जगह गिर जाता है. जैसे एग्जाम्पल हम बात कर सकते हैं मुंबई क्लाउड बर्स्ट विच टुक प्लेस इन 2005, देन ले क्लाउड बर्स्ट in 2010 and केदारनाथ क्लाउड बर्स्ट in 2013. So there are three condition, basically rapid convection, high temperature, high humidity level, the funneling effect which take place in the mountain valley region, and the drop, the rain drop which is too heavy for the clouds to carry and it drop down suddenly in a quick flash. So this was all about the formation of the cloud burst. Next we'll talk about tornado. So tornado, it is very much prevalent in USA. इंडिया में भी होता है बट इतना हमें नहीं देखने को मिलता है, बट यूएसए में इट अकर्स वेरी रैपिडली एंड इट इज़ वेरी प्रिवेलेंट देयर. सो टॉर्नेडो, दे आर अ वायलेंटली रोटेटिंग कॉलम ऑफ एयर that extends from a thunderstorm to the ground. From the thunderstorm to the ground, it extends. It appears like a funnel. It appears like a funnel shape which is descending from the cloud. The wind speed goes up to 400 kilometers. Here the wind speed, it goes up to 400 kilometers. It is formed when changes in wind speed and direction create a horizontal spinning effect within a storm shell. So it is formed when changes in wind speed, जब विंड की स्पीड में चेंज होता है, उसकी डायरेक्शन में चेंज होता है, क्रिएट्स अ हॉरिजॉन्टल स्पिनिंग इफेक्ट विद इन अ स्टॉर्म सेल. दिस इफेक्ट इज टिप्ड वर्टिकल बाय राइजिंग एयर मूविंग अप थ्रू द थंडर क्लाउड्स. This effect is tipped vertical by rising air moving up through the thunder clouds. Okay, so this is how tornado is formed, and it is it is more prevalent in USA. Next, we'll talk about the water sprout. So it is a whirling column of air and water mist, which is similar to tornadoes on land. Okay, so they are associated with severe thunderstorm and winds along the water surface. So water sprouts, they occur along the similar to thunderstorm, but they occur along the oceans, and the tornadoes, they occur along the land. Okay, so this was all about the rainfall, the thunderstorm. Thank you so much.